Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the XML document schema. First we will need that what is the need for an XML document schema. Then we will define the schema within the DTD, the document type definition as well as the XML schema in both the ways, and see what are the advantages and disadvantages of each of the types. Well, we know that the database system is provided us to make a schema before we are considering a database into action. The schema means the infrastructure of the tables or the relation of a database and how the relationship can be built on the tables or relations to make the database in a meaningful purpose. Now the XML, as we know, it is morely with the data concerned from one application sent to the other application. There is no such type of schema that is built on every relation. We just put the data into mentioning user-defined type or data types and tags. For that, we will need only the values and no schema in it. But if there are no constraints that is mentioned within the structural part of a database, then it is not meaningful to have it. That means sometimes we need to have a schema for an XML document too. So first we will talk about the DTD, the document type definition. The DTD provides a basic structure to create an XML so that it can support an infrastructural one to the data that we put into the XML schema. Now we will talk about DTD strongly because XML schema is another way to define the infrastructure of an XML database. Now first the DTD. The DTD provides many of the operators and the syntaxes that supports for making an infrastructure to the database to provide with the values and store it within the XML. First let's look at each of the operators and their use and how they can be used to define the database for an infrastructural purpose. So first to include an database, we should name is a doc type. The mentioning doc type keyword before any of the relation that mention that it is considered as a document type or a database. Now we will introduce each of the relations inside the particular database. See that the XML can contain in a root tag either an attribute or in a single tag or a nested tag in it, which we consider as a relation. But there was no meaningful way to describe the tags as a relation because it is more concerned with the data. Now in the particular database on a DTD definition, we need to adhere that every database should have relation and the relation can have more relations or attributes in it. Now let us look at this one. I have mentioned the doc type university to signify that the database university. When I am mentioning the element before the university, this means now I am considering university as a relation. Now it becomes an element to our definition in XML. So the university has this one, that is every relation that is included in the element university. And now the or sign includes that we will have department or course or instructor or teachers, or we can have more relation. So how to signify that we are not including it in the list but is as a basic one, along with that we add more information. So the plus sign signifies that we have one or more information. That means one has already been specified, plus means or more information are there, but there should be at least one information if we are using the plus sign. So now our next element is a department, which is a part of the element university, and the department has got the department name, building and budget attribute. So whenever we are mentioning attribute, we can separate this with a comma operator. Just look at this convention. Plus sign stands for one or more information, whereas star sign stands for zero or more information. So if we have a star or asterisk sign preceded and followed by any arguments, then we are mentioning that argument can have zero value, that no value, or more value in it. Now, if we have question sign inside an argument, then we are specifying that either the value should have only one or no value in it. That means 0 or 1. So it is 1 or more, 0 or more, and 0 or 1, the argument specified for plus, asterisk, and question. So we will first define the definition of department, course, instructor, and teachers relation. So each relation here will be considered as an element because DTD supports only elements at the lower level. Now that we have defined each of the relations, we need to define each of the attributes inside a relation too. When we are using the keyword PC data, has species data, then we are mentioning that we are having a text or normal text in the department name. Now the PC data stands for parsed character data. That means a sequence of characters as a text. So now I have described building and budget as PC data too. So we could have described each of this like the CID, the credit, ID, name, and salary all as PC data, because it is always better to have all the data in a string format and then convert it into an input if there is a need for a numerical calculation. So we can have all other data stored in it as the PC data. After that, my document university will be closed. That means the DTD for a university database has been defined in this way. Now there are two other special type of declaration, that is hash empty and hash any. When we say hash empty, that means we are specifying that the content of that particular attribute's value is empty. We will not store any kind of value in it. And for hash any, that means other than the PC data or text, we could have stored any type of data like the numeric or a character or any data that is not mentioned specifically, store inside the attribute. Now we will require to know about more than one of this PC data, empty and any. So there are datas or there are types of it which we can use for the reference, for the namespace, and for any other reference part. Now if the sub-elements that is specified by the OR operator, just like this, that the department and the course, but within the attribute, unfortunately there is no ordering among them. Just like the department name, building, and budget, so there is no specific ordering that department name will become first, then building, then budget. We can just have any order of that particular relational attributes. So we have some of the data types to maintain to it if we need to specify an ordering of attributes to it. Now let us look at this DTD. We are saying that attention list or the attribute list that we are having for the element codes and the attribute CID. So the ATT list followed by the element name followed by the attribute name of type this and a special requirement of this. So C data, that means a character data, not a PC data means sparse character data, and C data means character data. Now hash required implies that this field's record we need to mention. So DTD defines the primary key constraint by putting a hash required, that there can be no null value attached to the attribute CID of element course. There should be any value that of a character type mentioned within that course or CID. Now it has not given a proper primary key reference because it has not mentioned any uniqueness to the key, that it has got required. That means if I got CS101 for two of the courses, it will accept that because uniqueness is provided not inside an DTD. Now attributes have type references or declarations along as default declaration to it. The default declaration to an attribute is required. Other than that, it has a type declarations of ID, ID ref, and ID refs. Now we will see that course element and has its definition along this attribute type declaration. See, here I have defined the building and budget as an attribute to the department because they have the default attribute value declarations. Now I want the department name as the required field, so I will define it specifically. Other than that, in building and budget. Now let us look at this one. The attribute list department, that is the relation name, and the attribute name department name is of the ID type. What do you mean by ID type? The ID type means that it is the ID to the relation department. That means it will hold default values or a different value for each tuple inside the department relation. So that is why in a way we are providing the primary key constraint in the relation. And followed by the hash required, obviously that provides a not null value constraint in an SQL. That means we have to provide some values in a department name on the department relation whose value will be different from each tuple from another. Now in the course also I will define the title or credits as the normal attributes and the course ID as an ID that is required. See, I have in course more than CID, there are other attributes that I want to space a type declaration to it. Now let us look at this attribute department name and followed by the type ID ref. When we say ID ref, that means we are referencing to another field on another relation. So the department name must find a reference to any other field or attribute in any other relation, but not specifically mention to which relation, just making a reference to any of the name, department name attribute or other relations. So here it can directly refer to the department name of the department relation, but the main problem lies within this DTD that we are not referencing to a relation, just making the reference. Now the ID ref and ID reps are most alike same, but with the difference that instructors can be present or cannot be present in a department. So when we are referring to the instructors, it can find that some of the values are not present there. So I mentioned the type as implied, not required. Implied means we can even omit the field if it is not required. While the ID ref, there are two parts to the ID ref. That means it should belong to or refer to some of the ID fields in the other relation. So if the ID is not mentioned with the department name, then the ID ref with this department name for the course relation will go for an error because the ID ref or ID refs is not present if there is no ID mentioned along with the name of that attribute. See, the main difference between the ID ref and ID refs, we can visit clearly that ID ref goes for a particular attribute and ID refs go for a particular relation. See, I have mentioned instructor in the course attribute on a course department or a relation, and here instructor is the relation name, not and particular attribute. So when I refer to the instructor, that means I am referring to the relation, not an attribute, but it is more or like same because ID ref suggests that we are suggesting reference for an ID part of a relation. So when ID refs is made, that means we are referring to the ID part of that particular relation if that particular attribute name is the point of time not known to the user. So we can either use the ID ref or the ID refs. Meaning is same, that either we can refer to one or more instructor or we can refer to a particular instructor. If it is of a particular tuple or an attribute name, use the ID ref. If we know that from watch department there are many instructors in it, use the ID refs because it goes for a relation, not a particular tuple or attribute. Now for the instructor 2, the department name is ID ref because it is going for any ID reference that belongs to the department relation. Now that we have finished our university declaration on a DTD, now we will see that how to insert values that a DTD schema has been made on an XML. See, now I have used the university document name, not any more syntax along with it. So now I have defined it with the DTD. I can use the normal XML as a user-defined data type, that is university. Now let us look that I have made the department name at the attribute list, not the tags that I can use inside the department, while I have made the building and budget as the sub-elements to it. So the sub-elements that we are specifying within a comma inside the braces of an relation name or an element name, followed by the not sign, that is exclamation element keyword. But if I had made within an exclamation entity list keyword, that means that are the attributes to that element. So here department name is an attribute to the department element. So I am defining the attributes value as computer science, and now I will use the sub elements to define all the values. I will add one more department to it as a biology. So now I have department name as the ID attribute of a department relation. Now let us see that how to refer it to the course relation where we have department name as an ID reference. Now let us look at this course relation. The course followed by the ID reference CID is CS101, referring to the department name, that is use the ID ref with the computer science name. And now let us look at this one. Instructors will use an ID refs keyword, and which could have more than one value to it. That means one course can be instructed by more than one instructor. So now I have the instructor IDs, that is ID refs, no separation of comma between them within an included inverted comma. See here in the next course we have the CID and the department name, that is referring to the biology department, but only one instructor to it. So it is possible to have one or more instructors within the ID reps reference. So now let's look at this one, salary attribute or a sub-element of an element instructor. We have used 65,000. So other than using a PC data, we could have used #any. That means any type of data we can include in the salary field. Now in this way, we could have inserted other values of the instructor for 821 and 453. I am not inserting those values here. Now this ID ref and ID refs, as we can see that it is same like in reference or the foreign key constraint in an SQL or a database features. So it is more like the reference part. But with the DTD, we have the following disadvantages. The first one, the typing of a sub-element. That means if an element has been made an introduction to the sub-element of an element, we cannot type it more further. That means a particular type, which type it will be, we cannot do it inside the DTD. The second problem is the unordered list. Whether we are having the odd sign, the star or the asterisk signs, we all have an unordered list of the particular sub-elements inside an element. Now the attribute names can be specified by the comma and separated from each other, but there is no way to mean that it will appear only once. We cannot do this within the DTD. And the third one is in the DTD, we cannot go further for an ID ref and ID refs to a particular attribute to the name. Say when we are mentioning department name, that we have already talked that it is not being referenced that to which relation it was there. So if there consists more than one department and we have department name as their part of the attribute or any sub-element, it will confuse between two. So if a course has the department name to it and another department has having the same course, so it will relate that course with that another course, whichever makes no sense to our database. It will not cause an error, but it is no of logical sense that we are making with the DTD. Now this type of problem, that the individual typing, the ID ref and ID refs, and also the unordered listing problem can be solved if we use the XML schema to it. So now we will introduce XML schema and see how we can solve the problems of the DTD inside an XML declaration. Now the problems of DTD that we have discussed has been solved in the XML schema. First, let's talk about the typing. XML schema provides individual typing like string, numeric, text. Also, it supports complex data types and a sequence. Complex data types means that a combination of the preliminary or the primary data types, we can have it as a complex type. And the sequence type suggested that if there are attributes sequenced one by one, or a query or a statement sequenced one by one, we could have used a sequence type to it. Now we will see that how to introduce a XML schema. We can introduce an XML schema other than using the user-defined data type, or not to confuse with the user-defined data type. First is the letter XS, then a colon, then followed by the name of the schema. Just like the namespace that we have used XML NS for the namespace, we can use the XS for the schema. So even we can use a schema for each of the namespace in the XML. Say for an instance that there are university tag, and I can introduce each of the university has got each of the schemas to it. That means each of the different schema to the different namespace. That is also possible. Now let us look at this statement. Now the statement provides that XS is the schema. I have used that as in a namespace and then given this one as the XML schema. That means the w3.org is the URL for having the schema using XS. Now we can use that XSD in the place of XS without changing any definition meaning to the XS. Now let us define the university that we have done with the DTD with an XML schema. So that is the basic statement to start the schema, and I have already described it. Now inside and replace the schema word with the element word that we have typed for DTD exclamation element. Here I will replace it with the XS element keyword. Now the name of the element should be given with the attribute name that is the part of the schema. We need not to define it explicitly on a user defined basis. But the value that is given to the attribute name should be given by the user. For here it is university. Now the type can also be an user-defined type or a built-in type. Here I will use the user-defined type because university does not get any type of the particular built-in data type. It will get a complex structures of all the clears and relations, attributes and all. So I will use a user-defined type, university type. Now the slash and ending sign define that this statement has been finished in XML. See, while having named the name element department, I haven't used a slash sign. That means it has not been finished yet. See, now the use of complex type, I have used T capital for the complex type keyword that is being defined by XS, and now we are signifying that the following statement will be of the complex type and get it together as in one complex type. Now when we use the keyword sequence, XS sequence means the ordering of the data. That means the following statement will be given in exact order they are mentioning. So we have solved the two problems. First is the type, that is individual typing for data. We can use the built-in data types. And now the ordering of the elements on a sub-element or an attribute, that we can use the sequence for it. See, I have used the department name that is a sub-element of an element department and has got an individual type string which is a part of a complex type, that is the department's type, and the sequence will follow that department name will precede any of the attributes that I will mention later. See, for the sub-element budget on a department, then we are using the type decimal. That means it will be a floating point number. So the floating point in XML schema is defined as decimal keyword. Now that I have closed the sequence tag, that means first department name, then building, then budget. After that, I have closed the complex type tag, which will have 2 strings and 1 decimal data type. And after that, I have closed the element tag to define that the element department name has been defined. Now we will define the more relations on complex and a course or the instructors. Now let's look at this element course. Now we then have mentioned the complex type and sequence here. So course is not considered as a complex type data type. It is just having the sub-elements name, the department name and the credit on the CID as the string and decimal as of to it. So there is no sequence that this ordering can go any name on, and we do not have the codes as a complex type. That means all this are separated from each other. Now we will move to the instructor and teacher's relation. So this is the instructor element, which is called the complex type, and the sequence of the ID, name, department name, and salary. See here, we can have the department name in instructor and course relation or the element 2. But there is still now we haven't mentioned the third issue, that is the reference problem to a particular reference, or how many number of reference can be made to it. For that, we will describe one more element, that is the teacher's element. Teacher's element is recording the instructor teaches which courses. See, here also in XML schema, we have one disadvantage or a lower allowance, that for every name that is being referenced to each of the relation, we need to define it with its individual type, not just make the reference to it. So now we have finished all our elements, that is the teachers, department, course, and instructor. Now in the first, we have mentioned a user defined type, university type. So if we have mentioned a user defined type, then we have to define that type also. Now till now we have not mentioned any of the references to each other that the course, instructor, and department have. So in the university type, that will contain all the references, the number of references to each other. Now let us define the university type. Now let us look at this statement. Access element ref equals to department. Here I am mentioning the references. The keyword ref refers that how many times the department relation will be referred in the XML schema. It is not mentioning that which key has been defined and which key has been referenced, that mentioning that how many times department will be mentioned or referenced. And these are the limit to the references. Minimum occurs is the minimum number of reference that can be made to the relation or element, and maximum occurs is the maximum. So 0 is the minimum time and maximum occurs is the unbounded, that any time the department element can be referenced by other elements. Now we will use the other references too. Now the default value for the mean occurs and maximum occurs is 1. If we want to change that value, we can use it just like this. If the mean occurs and max occurs has not been mentioned, it will take the default value. Now I have mentioned all the elements that has been referenced, one with a min occurs and max occurs attribute name, other with the default values. Now that I have completed my schema. Now we have based a basic schema on an XML. Now we will define the primary key and the foreign key constraints on this XML schema. First we will define that how to know a primary key within a relation. So we can define it just like this way. First we have to mention a key name. That means we have to mention by what name the key will be referenced. So here the primary key on the department relation will be given a dipped key name. Now here the selector XPath. This attribute defines a path that express the scope for the constraint, that is the primary key here. So now my primary key for department, that is depth key, will have its scope. That means it can occur and execute only in the university and department to it. No other relation or element can access to this key. Now the field XPath defines all the fields that will constitute of that key. So now my primary key will have the department name. So the department name is the field. Other than we can specify the other names if that is a combination of keys as a primary key. Now that we have constrained our primary key, we will see how a foreign key is referenced from this primary key. See here in the foreign key constraints, we need to mention the foreign key's name in the access name attribute, followed by in the refer attribute, we have to mention the key name for the primary key on that field. See, we do not mention the field name here, we are mentioning the key name for the references. So in the key name, which will in turn points to the field name on a relation. For the selector XPath is same as the primary key, that it has got its life on the scope of university and course element. Now the field has got on which field to which field it is actually having reference to the different key. So department name on the course element is reference to the department key which has got the department name or the department element. Now, other than creating the primary key and this foreign key references to a minimum and maximum number of allowances, that means if I say that an instructor should be related with only 2 of the instructors or the courses, then we could have made the references to only 2 by this max occurs relation on the reference keyword. Now in this way, the XML allows also the inheritance to inherit the specialized types on a complex type and other data types. So these are the features of XML and advantages over the DTD that we have discussed previously. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.